Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. On this edition, we return to the final chats with makers at the first Do-It-Yourself Day at the Museum of Applied Arts and Sciences. But first up, here's the news about bionic bacteria. Augmented bacterial cells. Researchers at Berkeley Labs' Materials Sciences Division have fed bacteria with compounds that the bacteria secrete as tiny solar cells that convert light into electrons they metabolize for energy. Carbon dioxide and water into acetic acid as a feedstock for industry. Acetic acid can be made into fuels, foods, plastics, and pharmaceuticals. Humans take electrons for energy from our food and breathe the waste electrons out by combining oxygen with carbon to make carbon dioxide. Some bacteria from soil and lake beds called electrotrophs can take electrons directly into their metabolism from an electrode. The first electrotrophs discovered in nature eat metal and breathe the used electrons out by oxidizing the metal, rusting the metals. Morella thermoacetica is a bacteria that lives in soil at the bottom of warm bodies of water, where it metabolizes the nutrient nicotinic acid by combining water with carbon dioxide to make acetic acid. Nicotinic acid is part of the vitamin B3 complex. Acetic acid is the main ingredient of vinegar. Morella thermoacetica is also an electrotroph. It can feed on electrons from an electrode. The researchers fed the Morella thermoacetica bacteria with cadmium nitrate and the amino acid cysteine as a sulfur source, so that they made dots of cadmium sulfide nanocrystals all over themselves. The nanocrystals of cadmium sulfide act as solar cells, converting light into electrons that feed directly into the bacteria's metabolism, allowing it to make much more acetic acid from carbon dioxide and water than it did on its own. The researchers put the augmented bacteria through several 12-hour day and night cycles to mimic a natural environment and found that the bacteria produced extra acetic acid in the daytime and the nighttime. The researchers suspect that some solar energy gets stored in the daytime in NAD compounds that are related to the NAD compounds we use to store energy in our mitochondria. There may also be compounds that are part of the way along to becoming acetic acid, and these get metabolized into acetic acid at night. The researchers aren't sure yet. Either way, Morella thermoacetica with cadmium sulfide crystals make extra acetic acid during the night as well as the day, ideal behaviour for something using solar power. Vats of the bacteria sitting in the sun could churn out acetic acid to feed to other genetically engineered bacteria to make plastics, foods, fuel, and pharmaceuticals, while taking carbon dioxide out of the atmosphere, 24 hours a day. Their paper was titled Self-Photosensitization of Non-Photosynthetic Bacteria for Solar to Chemical Production, and was published in the journal Science. The researchers presented their results at the 254th National Meeting and Exposition of the American Chemical Society. At the same meeting, P is for plastic. Researchers from NASA, in collaboration with Clemson University in South Carolina, have found strains of the yeast, Yersinia lipolytica, can eat urine and with help from cyanobacteria that breathe carbon dioxide, make plastic for 3D printers. So astronauts would never run out of feedstock to make the things they didn't bring with them. In space, you can't afford to waste anything because it costs so much to launch, storage space is so limited, and the distances are so great. Other strains of the urine-consuming yeast can make foods like omega fatty acids that can't keep for more than a few years on the shelf. The yeast Yersinia lipolytica is commonly found in cheese. The work is in its early stages, so the yeast isn't yet very productive. Right now, it would take a 1,000-litre tank of yeast to produce enough plastic to print a spanner. In the light of the previous story, I wonder if the bacteria that fix the carbon, and perhaps the yeast itself, might be helped along by cadmium sulfide nanocrystal solar cells for greater efficiency. Just feed them cadmium nitrate and cysteine to find out. Lead researcher Mark Blenner presented the team's work at the 254th Annual National Meeting and Exposition of the American Chemical Society. Hopefully, the Berkeley team and the Clemson University team will chat at the conference. Right now, for space, pack everything you need. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network. And podcast over the internet on www.diffusionradio.com. And now the last of this year's interviews with makers at the Do-It-Yourself Day at the Museum of Applied Arts and Sciences in Sydney.
Hi, my name's Anthony. I'm the president of Create UNSW.
What sort of things are you showing that people have made today?
Today we have our UAV from a project that we're working on for the Land O' Lakes Challenge. So it's a quad plane, so vertical takeoff and landing. And the idea is the plane will sit at a base station, recharge, and then take off, survey some farmland, come back home, recharge, and then take off the next day. It's completely autonomous. It's meant to fly for 3 days at the competition, unmanned. Over on this side, we have our prototype from the Vivid installation. So we were a part artist in the 2017 Vivid Sydney. This one here, we entered Crystallize. So the idea behind Crystallize, so it's an interactive mural. It reminds us to cherish the truths and differences within ourselves, and as the mosaic fades, leaves a pair of wings behind the viewer. It's constructed from plywood, core flute, waterproof LED modules, and controlled by a microcontroller.
So the Vivid Festival is sort of a festival of lights with sort of interactive high-tech displays.
Correct. So there's a few really nice ones around there. So the idea is each artist puts out interactive displays, or could be static displays, which have different messages and things like that. So here is our entry into the DRC challenge up in Queensland. So the idea behind this one here is we have to design a autonomous car, or little RC car, that can avoid other vehicles as well as obstacles and also stay on a track. So the competition started in 2016. We won that one, and we entered in recently to the 2017 competition, and we won that as well. So we beat Queensland. But yeah, so the idea is to develop autonomous technology on something really cheap. So there's a price limit of under $1,000. So program everything ourselves, manufacture the car ourselves, and hopefully make it work. But yeah, that's that one there.
So is this a Raspberry Pi computer, then the little box on top?
So the little box on top is an Intel NUC. So the team this year decided to go a little bit fancy with their computer image recognition. So we entered in two teams. So one team used OpenCV to process the images, and the other team used MacLeod to do their image processing. The guys who used OpenCV won the competition. The MacLeod dudes came fourth.
So what's OpenCV?
So OpenCV is an open source computer vision library. So it works on Python, C++, and a whole bunch of other different ones as well. So the idea is you pretty much run it on a little computer, on a little PC, and then use your Arduino to do your motor control and processing like that.
And over here, there was someone sitting on a larger version.
Yes. So this one here is our large version ground vehicle. This was designed to give mechatronics students a platform to play around with robotics and robotics operating systems. So currently it's running a little laptop, and it's running ROS. So currently it's not running its autonomous avoidance. So at the front there it has a LiDAR. So what it does is it creates a map in front of it, and then creates a path as it's driving through. It can also be running, at the moment it's running on an Xbox controller, so it's giving it all the feedback. So you can also do manual control with obstacle avoidance. So you can actually drive this around, drive it out of a wall, and it'll completely avoid it.
So what sort of power is that? Are they just lead acid, or are they something more sophisticated, the batteries?
Just standard lead acid. So this pretty much came from a couple of scrap, I think it was old wheelchair motors and wheelchair setup. So the bottom two wheels are running really strong wheelchair motors, and the top batteries are lead acid from a wheelchair.
And the rest of it, so you've got Robot Operating System, ROS.
Yep.
running on a laptop, and is that an Arduino controller at the back?
Correct, yeah. So the laptop gives a PWM messages to the Arduino, and the Arduino then goes into the Sabertooth, and the Sabertooth controls the motors.
So the Sabertooth is the Arduino board?
So the Sabertooth is the motor controller, sorry. Yeah. It gets the data from the Arduino to the Sabertooth.
So this is where you sit on the laptop rather than the laptop sitting on you?
Correct.
So UNSW Create, are you all University of New South Wales students?
Correct. We're also open up to the public as well, so we have workshops running 6 to 8 p.m. at the MacLeod Innovation Centre at the UNSW campus. So all workshops are open to everyone, but the projects are solely to UNSW students.
Are you the only university maker club that's open to the public?
I think so. There's quite a few that aren't. So I think we're the only ones who have workshops running for open to the public.
That's quite amazing. So what sort of workshops do you run?
So everything between soldering workshops, basic electronics, basic CAD workshops, OpenCV for more advanced users, and also this semester we launched a mini quadcopter building workshop, which is pretty cool, something new. So the idea behind the workshops is to allow students to pretty much get some more further experience in university life, so sort of expanding their knowledge from outside the lecture theatres.
And how do people find out about the workshops? Do you have a mailing list or something they can be updated?
Yes, so if you go into our website, www.createunsw.com.au, you can find all our workshops there. Also, the times are listed there, and also all our there's a mailing list there, as well as all our past mailing lists are all there too. And
what sort of price are the workshops? Like if you were to go into the quadcopter one, how much would all the parts and the lessons cost?
So the actual workshop's completely free, so you can sit down and actually absorb some knowledge, or if you want to get some practical experience, depending on the workshop, we don't have a price for the quadcopter one just yet for the parts, but the Arduino workshops, the kits, we have a basic kit which is $25 and a full-size kit which is $45 for an Arduino Uno kit. They're all on our website as well, so we have a little stall on there, so for all university students and also schools, they can purchase some parts and things like that from us.
That's amazing. And you've got something else, another gadget over here in the corner with breadboards and everything.
Cool. So over here is our OpenCV project. This is more of a little basic thing that we show off in our workshops. So this one here will track different colours. It's currently being fixed up at the moment. As normal coding projects always go downhill. But yeah, it's pretty much the idea is it'll track different colours. You can also track faces, all programmed via Raspberry Pi and a couple of little breadboards and things like that.
That's amazing.
Awesome. Thank you very much.
You're very welcome. And anything else you want to say to people about UNSW Create?
We'd like to have more people at our workshops, so definitely come down. We're open to many people. It's a good place to learn and meet some new people as well. Just to also add on to that, if you need any help with projects and things like that, we also have a Facebook group where people on the community can come around and ask questions and interact with each other. If you go on Facebook and search Create UNSW, it should pop up there.
Terrific. Thank you very much.
No worries. Thank you very much.
My name's Annalisa De Lorenzo, and I'm the founder and CEO of MakerSpace and Company in Marrickville.
What does MakerSpace and Company do?
We provide all the gear that you might need to make whatever you want. So we operate a bit like a gym in that you come in as a member and you can use all the gear whenever you want to make your own projects. Or if you don't know how to use the gear or you don't know what you want to make, you can take a class and we'll teach you and we'll show you what you can do.
So do you run these classes often?
All the time. So we've got classes running every Saturday, on Monday and Tuesday nights and Wednesday nights and Thursday nights. So yeah, we've got lots of classes running and the program's always developing, and that's across everything from ceramics to electronics, woodwork, metalwork, welding, knife making, heaps of stuff, lots of stuff.
Is it a big space?
1,200 square metres, so it's a big warehouse in the industrial area in Marrickville, right near Sydenham Station.
And how did you come to start this space?
I studied design a while ago and then started teaching design at a couple of different universities and just watched so many graduates come out who were full of ambition and drive and had nowhere to go. So they had no gear, they didn't have the business skills they needed, they didn't know how to get started, and it was really tough. So it wasn't an immediate connection we made. First we did a lot of exhibitions and events and business training, and eventually got to the point where we realised that if you want to make something, you need to be able to make it. And so we try to get rid of all the barriers that get in the way to that. So that's why we provide the workspaces, we provide the machinery, and we provide the expertise so that you can know what to do and do it well.
And do you help them start a business with this as well?
Yeah, so we have classes to help with business training. We also have a few studio spaces and residencies to help with people. And also we try to connect early stage businesses to people who are a bit further along so that they can mentor each other with peer-to-peer mentoring. And there's way more we want to do on that front as well. So we've just scratched the surface.
And is there any typical age group or type of people you get in?
We have everyone at MakerSpace. It is technically a space for adults, but kids can come with an adult. But we have recent graduates up to people in their 70s and 80s coming through. Probably the majority of people are sort of 30 to 45, and a lot of them are from the kind of Sydney inner west area, but we have people also travelling from as far as the Blue Mountains and Newcastle to come and use our gear. So yeah, it's pretty diverse.
Is membership expensive?
We keep it as cheap as we can. So basically, if you want to try out the space, you can get a first-timer pass. $50 gives you 2 visits, and that gives you access to everything. We induct you, show you how to use everything. If you like it and stay on, Essentials membership is $100 a month. That gives you up to 10 visits. Again, access to everything, access to our staff and facilities, and then it goes up from there if you want to be there full-time, if you want your own space, things like that. So,
does that include the classes?
No, it doesn't, but you get a discount on classes. Yeah, and you don't have to be a member to take a class. Anyone can come in and take a class. I think the best thing to do is to come and visit. I think people find it hard to quite wrap their head around what it is and how it looks and how big it is. So we're always open to the public. People are always welcome. You don't need to make an appointment. Just drop in and have a chat and check it out, and we'll show you around.
So you've got kilns, and what other sort of equipment do people train on?
Oh, everything. So in the metal department, we've got a whole lot of different welding facilities. We've got machinery for manipulating sheet metal rods, pipes to make all sorts of things. In woodwork, we've got full sheet panel saws, we've got lathes, we've got thicknessers and planers. We've got, in ceramics, a whole bunch of wheels. We've got a slab roller, we've got kilns. We've got a whole amazing electronics and mechatronics lab that's been set up. We also have, in textiles, industrial sewing machines, overlockers, knitting machines, and then we're also set up for screen printing and etching. And then we've got a co-working office for people who want to do creative stuff that's maybe a bit more computer-based. And we're about to set up a darkroom for photography too. So we've got a lot of gear.
And where can people find you online?
We are at MakerSpace, makerspace.org.au.
Well, thank you very much.
My pleasure, thank you.
Well, I'm Bob. I work for the Bow doing the repair cafe, and we will do anything from electronics to lawnmowers. So if you've got a problem with something, bring it along. If we can't fix it, we'll try and refer you to where you can get it fixed or where you get parts.
So people throw out too many things, do you think? When something just doesn't work, they give up?
Absolutely, particularly in certain suburbs. Certain suburbs, you can pick stuff off the street, plug it straight in, and you've got a functioning unit. And other suburbs, it's really destined for the tip. But whatever you've got, we'll try and fix it and keep it alive for this generation and maybe the next.
So I saw you working earlier on an old record player. It looked almost big enough to be a valve-based one, or was it transistors?
No, it's certainly the old valve radios, and it's about a 50s model. Yeah, at least a 50s model unit it was. Radio portable, they called it in those days, not like the light stuff you get today. But it's a unit that find very hard to get parts for to keep it genuine. We can put knobs on that aren't compatible, but they'll fit and they'll work. So we can do things like that. But if we're restoring it, people like to have the original fittings, and they're very hard to come by.
And that was a lady who just came here in the museum?
That's correct, yes. Yeah. She lives around the Blakehurst way, but she knows Marrickville, where the Bower is, and she's happy to come up there and get things fixed.
And is that an example of the sort of range of things, from very old things to very modern things?
Oh, yes. Well, we do things from we've got Art Deco stuff, clocks, radios, and the likes, lamps in particular. We have some excellent figurines, solid bronze in the Art Deco era, and they're very good. People like to keep them.
What about things like mobile phones?
Yes, we can do mobile phones to a degree. There are certain things we can't do on a phone because you've got to have specialised equipment. But in the main, yeah, We can fix, get it going for you, screens, plugs, chargers, all that type of thing.
They're pretty modular, these modern mobile phones, aren't they?
Well, yeah, but a lot of them are designed not to work on. They don't like you pulling them apart, and so many of the stuff you get today, we find that the screws, they develop screws that we don't have tools to undo, and when you start to make tools to undo them, they change the screw. What we found now, you can get tool boxes that have got an array of sorted heads to undo these screws, and so what they do, they sink them down about 3 or 4 inches further so you can't reach them because the heads are only that long. And there's an array here of the tools. Those kind of heads, once you've got the head on, you can't get a long reach out of them. So you have to either buy another set of expensive tools, order them in from overseas, go to a specialised tool place to buy them.
So are you part of the right to repair movement? You heard of it?
No, I haven't heard that.
So the idea is that, as you're saying, they're making it harder and harder for people to repair their own things. Apple even gets special screws needing special screwdrivers that only they have. And so there's a movement started in the US, I think, of people to say, well, we have a right to repair things and it should be enshrined in law so they can't stop you trying to repair things.
That sounds very interesting. I'll have to look into that. But I've come across things now where they don't use screws anymore. If they're building them with plastic, they mould them, so you've got to break the plastic to get to something to repair it. And you know, breaking the unit to get to it is self-defeating.
And a lot of phones now, you can't replace the batteries.
No, that's right. Well, actually, I have one. I can't even get in to pull the battery out. So it's,
Frustrating.
very frustrating indeed, particularly when you're a handyman or you have a keen interest in that field and they frustrate you at every step.
So the repair centre, the idea isn't for people to come and bring you things for you to repair, it's for them to learn.
Well, that's the idea. It has to be explained very carefully to them to start with, because so many people come in with the expectation that, oh, I've got this, can you fix it for me? And, well, it can be fixed, but you have to help. Now, there are certain things in the electronics or the electrics that have to be done that we do because there's licensing involved and there's danger with electricity. We might get you to pull something apart, undo the screws, but we will do the electrical component of it. Otherwise, you do it wrong, get zapped, you come back at us. So we've got to avoid that. We don't want to see anybody hurt.
So this is quite an interesting lot of skills that you're showing people what to do.
Well, we do have a broad spectrum of skills, from the mechanical to the electronics to the electrical. A lot of people confuse electrical with electronics. They're a totally separate field. And we have people that can do electronics, specialise in it, and common people like myself, can do the electrics and do it in a safe manner and explain it to them, and hopefully they learn something out of it.
And you're based in 2 different places in Sydney?
Yes, right at the moment we have the Marrickville base at the Bow, which is the Marrickville Community Centre in Addison Road, and we have the Parramatta establishment, which has been open for about 12 months now, I think. We do workshops where people that want to learn skills, everything from upholstery, carpentry, we do basic carpentry schools, we do crafts, arts and crafts, tiling and all that type of thing that can be done at the 107 establishment, which is at Redfern. So 107 Redfern is actually their address, 107 Redfern Street, and there's a workshop out there fully catered for with tools and carpentry. And if you want to do the work yourself, you can hire a bench out there for $5 an hour or something, $10 an hour, or you can do daily rates. And if you're a hobbyist, it's an excellent place to go and get yourself worked out in.
So don't throw it out, bring it in and learn how to fix it?
Absolutely, no worries.
Well, Bob, thank you very much.
My pleasure. Have a good day.
Next week, we look at pulsars with CSIRO.
So you see, women need to know as much about science as some men do.
And that's all from us this week on Diffusion. Would you like to hear your voice on radio? Record a voice memo on your phone or use the voicemail tab on the website. We need more people contributing stories to Diffusion. Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. And please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Join my patrons in supporting the show at patreon.com/diffusionradio. The news music was Rynos theme by Kevin MacLeod of Incompetech.com. Checking production was Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2 RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 NVR in Nambucca Valley, and 3 MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos from this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords, so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.